And no. Shh.
Hey, it's my dad's birthday. It's your dad's birthday.
Happy birthday, Phil's dad. Okay, today we are having more fun.
Okay, got it.
With more fun with polynomials. Okay, guys. Shh. Hey, at this time, I have everyone's attention up here, and if anyone has anything that does not belong to them, get it back to the rightful owner.
Go.
Okay, and I don't have a book handy for this. Okay. All right, Eliza, you had a question on numbers.
I think it was 57 and 60.
I thought we were.
Can you remind me of the page number? 334.
Yeah.
Just open to that. 333. Okay. Number 57 on the homework that starts on page 333. The polynomial is f of x equals negative x to the sixth. We did y, which your book says f of x. And for now, f of x and y are interchangeable. We'll talk about the difference soon. Okay, for now we have f of x equals. F of x and y, interchangeable for now. There is a difference. We'll get to it soon. The difference won't show up in this unit early on. Negative x to the sixth plus 2x. I left something out. 2x cubed minus x. We use the first term in this case. Arturo raised a great question that I wasn't clear on yesterday. We don't always use the first term. You use the term with the biggest exponent. Does the first term happen to have the biggest exponent in this case?
Yeah.
Okay, good. Now, is this exponent odd or even?
It's even.
It's even. So, because it's even, we know we're either talking about a touchdown or a marionette.
Wouldn't you add it with the, are we trying to solve it?
No. All we're trying to do is determine its end behavior. Okay? So this is either a touchdown or a marionette. The leading coefficient, the number at the beginning, is that positive or negative?
Negative. So it's a marionette.
Negative. So it is a marionette.
Wait, can you say it again?
There's an E on it.
There's an E in the end. Okay. Exponent tells you it's positive. It's the exponent being even tells you it's either a touchdown or a marionette. The negative number at the front tells you that it is this one.
What's going on?
Okay. This is called the end behavior of polynomials. Okay, and it's this. Well, you missed a lot yesterday, Jeremy. Check out the video and we'll get back to it. Okay, I'm not going to repeat. I'll go over it again in a sec. Yes, sir. Yes, and I said last night, yesterday in class at the end, that I didn't get to that notation, so you would have to use the words.
Oh.
All right, so I'll teach that notation today.
Oh, great.
Okay.
Good to know.
Now, number 60, Eliza also asked about. So,
60.
yeah, so this is f of x equals x to the seventh minus 3x cubed plus 2x. Okay?
It's always the leading coefficient that has the largest.
You always use, you take the whole, guys, shh. Okay, man, just ask a question. You take the term, what term has the largest exponent?
Yeah, I know, it's always the first one.
Only if it's written in standard order. Were these all written in standard form?
Yeah.
Were there any where it was out of order?
No.
Not really.
Not yet. Yeah, okay, these are all good, yeah. Okay, so we use the first term, it's got the highest exponent. Is that exponent odd or even?
Odd.
Odd, so we're either looking at a ballerina or a reverse ballerina.
Dance.
I know, they're doing some dance up here. The leading coefficient is 1. It's positive 1. So which is it, a regular ballerina or normal ballerina?
Regular.
Normal ballerina or reverse ballerina? It's a normal ballerina. Jeremy, to quickly recap, okay? This is all based on the behavior of a couple of graphs. One of them is y equals x cubed. If you just graph y equals x cubed, it looks something like that. And I called that a ballerina shape. And what it turns out happens is, this is a good review for everybody, if you have a positive leading coefficient and an odd exponent, the ends of the function will always behave something like this. In between, it might do all sorts of crazy things. I don't know how this behaves off the top of my head, but it might behave something like this. The point is, way out here at the ends, it's going to be going way up to the right and way down to the left. And that characteristic is true of every single polynomial that has a positive leading number and where the highest exponent is odd. Okay? If you have if the highest exponent is even, it behaves something a little bit like a parabola. Parabolas have both of their ends going up forever. If the leading coefficient is negative, you don't get a smiling parabola, you get a frowning parabola, right? Now this is not a parabola. Parabolas are only x squared. This is x to the 6th. It might look something different. I don't know exactly what this looks like. We'll get into that later. But whatever this thing looks like, because the negative number's in the front, and that's an even exponent, maybe it does something like this. But at the ends, it goes down forever, both on the left and the right, like a puppet, its arms. So that's what we're talking about. We're starting to classify these things. I told everyone yesterday it's kind of like biology. It's like classifying animals. You look at something. Does it have scales or does it have fur? It's either a reptile or a mammal. We're starting to do that sort of thing with graphs, more complicated graphs. I did not teach the notation yesterday, so I expected in your homework to see the words. May I erase these now?
Yeah.
I have a question.
Directly related to this?
No.
Can I wait then?
Yeah.
Thank you. Okay. Let me teach the notation today that your book uses. Okay.
Why can't we just keep them there?
Well, we're going to use both, but I want you to know the notation. We'll more often use the words. For one thing, the words are shorter. Okay. Now, for the first type of function, if we're talking about a touchdown, graph, okay, what happens is, as you look to your left and as you look to your right, the function goes up forever. Here's the math way to describe that. As x approaches infinity. This is what this means in English. These symbols. Write them down, learn them, love them, live them.
Doesn't one mean infinity?
I don't know how to write that.
As, you put an X and an arrow and a sideways
Alright.
8. This is read as x approaches infinity.
Oh, that's right. I was right.
Okay? As x approaches infinity. Now, here's what infinity actually means as far as we're concerned. Infinity means, as on the x-axis, as far to the right as we can imagine. As x goes as far to the right as we can imagine, what happens? Well, if you have a touchdown, as x goes as far to the right as you can imagine, f of x, which we're using the same as y, goes up as high as you can imagine. This is read as f of x approaches infinity.
Where are you?
And these two lines together tell me that as x goes as far to the right as we can imagine,
Is f the function?
f of x is the function. But we're using it to mean the same thing as y here. Okay?
Oh, so is this when we...
Hold on, let me finish the sentence first, Stevie, and then I really do want to hear your question, okay?
Sorry.
As x goes as far to the right as you can imagine, the function goes as far up as you can imagine. As x goes right, f of x goes up forever. That's what the infinity means. That's what this notation means. Any questions on that one? Yeah. Now this is only half of the touchdown description. To fully describe a function that behaves like a touchdown, you've got to talk about what it does to the left as well.
So that represents both x approaches infinity and f of x approaches infinity.
This represents both x and y, but only on the right side of the graph. To talk about the left side of the graph, I have to include this. I have to say now, as x approaches negative infinity, and that means as x goes as far to your left as we can imagine, f of x also approaches positive infinity, and that describes the function going up to the left as far as we can imagine. So to say touchdown in math, you have to include all four of these lines.